Hello. Hello. Hello, sir. Good, how you doing? How you doing, sir? Good. Hello. What now? CIS290 boot camp.
Nej? Don't worry about it, but you just send me your, you want me to? Yeah, that'd be cool. I mean, don't worry. Yeah, don't worry.
Go ahead and log into the Kahoot if you haven't already, so we can start right at 7:30. Great. We're waiting on a couple more to get in, and then we'll get started. It's on chapter 15 on pointers, which we're covering this week. I'll give about another minute and then we'll get started. All right. Here we go. Good job. Arrow is the answer on that one. Address variables. Asterisk in front of a variable makes it a pointer. The ampersand sign on this one changes a variable into a pointer. This one is assigning the reference ID, the memory ID of the thing into pointer. True, a pointer can be assigned by another pointer. Job. I'm a little under the weather tonight. I'm not my cheery self as normal, so you probably didn't notice that already. So we'll try. We'll make it through though. And so I wanted to show you. Just finished up last week. 10 weeks with a fourth graders from Galapagos School in downtown Rockford. Every Friday I met with them, and they did Ozelbots and coding, an hour a day, an hour each Friday. These are some of the pictures of some of the kids that finished the class. And they got an Ozelbot when they were finished and a certificate of completion when they were done. And they learned JavaScript, drag and drop coding, how to manipulate a robot with coding. All right. Want to make note in the top of our class, there's a final help app or final app help. You click on that, it'll bring you to the app requirements that I added a couple weeks ago. along with some quasi deadlines just to help you meet some milestones. Like coming up would be April 2nd, app basic functionality, April 9th, app testing, debugging. And you can use the Replit links to have folks test. Those are you doing the console base.
Not to put you on the spot, but are you bringing pizza for all?
Do what now?
Not to put you on the spot, but are you bringing pizza for all?
I'll talk about that later. Yeah, we have to change that a little bit. Yeah, we're going to have to change that a little bit. We are going to have pizza, but it'll be different than the last session. April 23rd, completing a website on GitHub or Weebly. If you're not for sure yet, I would suggest Weebly is an easy one to create a website if you're not HTML literate. It's an easy one to use. April 30th, uploading your final code to GitHub. April 7th, final presentation. And Jack mentioned about pizza. For most of my programming classes, I usually get pizza last night. And we are going to have pizza. It'll be the week of our final the week of your finals. I have to be here by the new guidelines on campus. And so I'm going to be here the week of finals, and we'll have the hour or two, whatever it is, slotted for this class will be open. And I'm going to let you guys come in and grab whatever you want to pizza-wise and snack-wise, and then you can hang out if you want to and do whatever. But I've got to be on campus that whole week for finals. Normally, because of the structure of our presentations, I always do the final presentations the week before finals. We'll still do it that way. It's just the week of finals, I will have pizza in this classroom during that time frame for our finals, and you guys can come in and grab whatever, hang out, and go to your next class for your final class. Make sense? So we'll talk more about that later, but that's how we're going to do it this semester. Anyway, as far as requirements go for the app, make sure it meets a real world need in your own life or somebody's life. The app's doing some function that doesn't have to be anything earth-shattering, just some function that's going to be helpful. Make sure there's comments throughout your code explaining what the code's doing. If you use input or CN make sure to do validations. For input, have at least 3 or more functions, 3 minimal. You can definitely do more than that. This is just minimal requirements for your app. That way you're pretty flexible on what you can do. The link for code helps here just links back to some links I put in there for our course for C++ reference helps that might be helpful to you. And this week we're going to be going over pointers. Next week, read and write to a file using Replit. There is ability in Replit to create a new file that we'll be playing with next week and have the ability to show you how to read and write a file in C++. Week 12, debugging, and then week 13 and 14 both, I will be here both weeks to help you finish up your final app. I'll be in here the entire time to help. And that doesn't mean you can't wait you don't have to wait till then to ask for help or to shoot me an email and say, hey, can you give me some help with this code that I need help with, whatever it might be. Sooner the better for me, because I have this class plus my Android class plus 2 or 3 other classes outside of the campus that I host clubs with, that I help all the students with their code. And so the sooner the better. If you think you're going to need help with something, shoot me an email so I can start helping you and working on that example for you. So that would be helpful if you could do that. And then week 15 is where we'll be presenting your final app. Starting in week 15 is presenting your final app. Okay, tonight we're going to be doing class or pointers. And this week 15 or chapter 15 was the reading for this week on practical C++ text. The slides, you should have a link to the slides in your 10 example. You can go ahead and click on that, and it should prompt for you to log in or something, I believe, on that link. Go ahead and I think it just asks put your name or something in there maybe. I don't know. Is that correct? Just have you put your name in there and then just submit it, and I should see your name show up here on the screen. Once I see everybody's name show up, we'll go over the slides. And you just have to put your nickname, whatever. It doesn't have to be, I'm not grading this or anything. It's just a way for you to see the slides better where you're at versus on the overhead. Sometimes it's hard to see on the overhead. There's only 9 slides, but I want to make sure everybody sees them. And so again, it's in week 10. Example is a link to the slide, and it'll be prompted to put your name in. Week 10 example. In week 10, look for the example module, and it's inside of that. You should see it for slides. And then as soon as you click on that link, it'll be prompted to put your name in. I believe that's all that's required, if I'm not mistaken, is just your name. Another moment there before somebody get connected in, or you can look off your neighbors if you don't want to connect to it. I'll give another moment here for everybody to get connected before I advance on. As soon as I advance these slides, you'll see it advance on your screen as well. So you don't have to click through it or anything. It'll do it for you as we go through them. All right. I'm going to go ahead and advance through here. So in the text for chapter 15, it used the terminology of things and a thing and a pointer. And the thing would be the variable type or variable declaration, like an integer or a string in this case. This represents the memory location. And then a pointer to that memory location. Pointers, as it said in the quiz and it says in the reading, are very small. They're not real large because they're just pointing to something in memory. That something is the thing or the variable in this case. Things versus pointers. Things, again, when you hear the word things in the chapter, refers to variables. Things can come in any size. Some may be big, small, can be floats, integers, doubles, chars, strings. Pointers can only come in one size, and they're fairly small. Again, because they're just pointing to a reference of a memory location. It can also kick out the value of that memory location, but it's only pointing to it. It's not holding any values, really just pointing to it. So also in chapter 15, I had a pretty good example, I thought, of the different iterations of the operators as it refers to pointers. The ampersand on any variable thing pointed to a pointer as an assignment operator will assign that thing's address, that memory address, to the pointer. Like in this example, it gives a memory address of 0x1000 with a value of 5. And it's putting it in the pointer thing underscore pointer. In the text, which really isn't a bad idea for chapter 15, talks about possibly underscoring and putting the PTR on the end of pointers. If that's helpful to you, that's great. I'm not saying it's not a good thing to do. Again, it's just letting you know it's a pointer. The B example there goes over a pointer assigning to the value of the address into other, which in other, this case would be the actual value. So instead of assigning the reference address or the memory address here, it's assigning the value of that address to a thing or to a value, in this case, a variable called other. Last example is if you want to update a pointer, you do it like any other variable. Just make sure when you update it, you have to include the asterisk in the pointer declaration, even though it's been initialized. If you're going to update it, you have to include it again. and then assign it an updated value. So here's an example program. Int thing var defines a variable. Int thing pointer defines a pointer. Notice it has the asterisk before the thing var or the thing pointer. Next line, thing underscore var assigns a value to thing, and then scene out thing var, which in this case should be 2. And then thing pointer, you'll notice on this one here, thing pointer, it's already been declared as a pointer on line 2. If you're just referencing or pointing to a pointer, something, you don't have to declare it as an asterisk in front of it again. Because you'll notice here it's taking the reference of thing, var, which creates that variable now as a pointer, makes that pointer to the actual initialized pointer called thing underscore pointer. Next line, we're updating thing underscore pointer. This time you'll notice the asterisk is there because we're changing the value. So when you change the value of a pointer, you have to include the asterisk before the pointer name. If you're just updating a reference to a value from a variable, like on the line above, you do not have to, okay? Then changing thing var to 3. Here we have a cout thing var. Another way of doing it might be something like thing and then just the pointer itself, thing underscore pointer, would print out 3 as well. So the output of this should be thing 2, thing 3, and thing 2. Go back to that initial last slide before that. So on the first cout, it's just outputting 2. On the second cout, it's the pointer's already been changed to 3. The thing pointer's already been changed to 3. And you'll notice here though, on the cout, it's not calling the pointer, it's calling the original variable thing var, which remember the pointer's referencing that the entire time, and it remembers it now whenever you call it as a cout separately. Lastly, to call 3 again, you can do it this way as well, which would be basically just calling what the pointer's been updated to here on this line, here in the cout. So valid pointer declarations, not celebrations. NT-IP with an asterisk before is pointer to an integer. Next one's a double pointer. Third one's a float pointer. And the fourth is a pointer to a char. And that's how you would declare it. Further on using pointers, in this example here, we declare int var as 20. And then a pointer variable called IP as an integer. And the next line is storing the address of var in a pointer variable IP. You'll notice you don't have to include the asterisk before IP on that one because it's just storing the value of that address. Cout, the value of var variable, var should be 20. Printing the address using IP. Address stored in IP is IP. Accessing the value of it, just using the asterisk IP, which would be the pointer of the IP itself. So we're going to look at now inside that example. If you want to go back to that tab for the example, we're going to look at the first one, which is the replit return pointer. I want to click on that. And this basically is going to return a pointer. And this one's going to help you really help you more with your homework than the next example, but this is a good example to help you with the homework. The homework this week has you enter in as many values you want to, and then it's going to tell you the max of those values. This program, all its job is to do is to ask how many numbers you're going to enter in. So you enter like 3, and you put in 3 numbers after a return key between each number. It's going to kick out the average of that in a pointer. If you look on line 6, declaring int n, int I, and int avg as 0. Yes?
Pretty sure line 11.
What now?
Pretty sure you can't do that. Line 11, int array n. Pretty sure you can't do that.
What was that now?
Line 11, int array n. Pretty sure you can't do that. You try to compile it. Pretty sure you can't do that.
What was that now?
Line 11.
What about line 11?
I don't think you can do that. Declare an array like that. Int
Yeah, you
array
can.
n.
Yeah. Yeah, you can. We'll run it here in a second. The next line here is basically declare int an array of 9, or array called air with n, and plugging in how many you put in the cin. And so say you put 3 in here, air will now become an array of 3. It'll loop it 3 times if we put 3 in here, and populate the cins of that 3 times. And then here it's going to average it out on the 18 through 20. On 18 through 20, you'll notice on line 19, it's taking average plus whatever array number is and just summing them together. On line 22, it's taking the average and dividing it by n, which is on line 8, which is the however many loops or numbers you entered in. And then line 23, it's using the reference variable to the variable avg and creating a pointer to the actual pointer. Then on line 26, it's kicking out the average number. So let's go ahead and run this. I'll go ahead and stop mine and run it again. Refresh. So I'll go and put it in 3 there. And let's say I'm going to go and put in, let's see, 4, 3, 2. The average number of the array is 3. Okay. Why does it work? All we're doing is, if you look on line 8, we're getting the value for n, which is in this case 3. Then for each number, we're entering return key. On line 11, we're populating the array ARR with 3, okay, which is the number 3 is all it is right now. We're giving 3 dummy places for ARR as values. That's an array on line 11. On line 12 and 13, 14, 15, we're populating the array ARR with whatever input has been put in from the cin. The cin is done 3 times on line 14 to populate that array. 0, 1, then 2. Then in the for loop 18 through 20, goes through those arrays and puts it in the average sum with the ARR0, ARR1, ARR2, summing them together. Then on line 22, divides it by n, which in this case is 3, and comes up with 3 as the average on mine. So that's how it works. But this will actually help you probably more than anything. On the homework, we'll go over in a second. You're actually doing a max value. Here you're doing an average value, but this is a max value. So we'll X out of that, go back to the example, and go to the pointer example now, at the bottom of 10 example. There's a lot to this one. So the first one is done for you. In this one, we're going to go over it first, and then we'll run it. In this first example, on line 7, comment is declare a pointer for RBC student name. And so I call it RBC student name underscore pointer with the chapter 15 example noted this week to put an underscore pointer, maybe help you out. Line 9, declare pointer for RBC student 1 or RBC student ID, it should be. And so I declare that on line 10, string RBC student ID underscore pointer. Notice both 8 and 9 are what? Because of the declaration. What are they now? What is RBC student name underscore pointer, RBC student ID underscore pointer? They are pointers because of what? Because of the asterisk, right. On line 11, declaring string variable for RBC student. So I called it string RBC student name underscore value. 13, declaring a string variable for RVC student ID. Call it string RVC student underscore value. Then if we skip on down to line 27, because you'll be filling in some blanks here in a second, string ST or RVC student name equals Elvis Presley. Then string RVC student ID, I have 0, 1, 2, 3, 4, 5, 6, 7. And then 2 couts for the name and ID, student name and ID. Then line 34, I take the reference of the variable RVC student name, and now it's made it a pointer because of the ampersand, and I plug it into the RVC student name underscore pointer. I assign on 35 the RVC student pointer to the pointer student ID address with RVC student ID into the RVC student ID underscore pointer. Then on 38, get the address for RVC student name underscore pointer by just calling the pointer itself. Then on line 40, the RVC student ID underscore pointer. Then 30 or 42, actually getting the value of the pointer by putting in there the asterisk in the RVC student name underscore value. And then seeing out the value for RVC student name underscore value on line 43. On line 45, putting in the pointer for the value of the ID. And then 47, seeing out the value for the student ID. So I'm going to go ahead and run this with you. Let's go ahead and run this together. Oh, what was that? I'm sorry, I can't hear you because of my line 1. I messed up on it. Okay. I probably did a fat finger when I took off the answer. I probably got rid of it. Yeah, there it is. Thank you. So get rid of that. A little gobbledygook in there. Thank you. Let's run it now. Thank you. So the first one's Elvis Presley kicks out the, that's just the first 2 variables. Elvis Presley, 0, 1, 2, 3, 4, 5, 6, 7. The address for student name. You'll notice the address for student name and student ID pointer are different just a little bit. And it's going to be different maybe for each computer here. It runs upon, in this case, a browser, the web server, wherever it's located at. And then the last 2 are the values for the student name value and the student ID value. Again, the reason the value was pointed out on that was because a pointer was included with the asterisk. So what I'm going to have you do is, if you look on line 16 through 23, you're going to complete initialization for RVC student 1. Use the example above to help you with that on line 6 through 14. Then you'll go down further on lines 49 through 60 or 70, and you will complete the RVC student assigning of pointer for the name, pointer for the ID, seeing out the references for both, the memory reference for both, and seeing out the value for both. So we're going to do that, and you'll use this as an example of what's already been done to help you. I'll give you a few moments to do that. I'll walk around, help you, and then I'll show you the answer on the overhead. Knock them out one by one. Leave you the comment line. You should be okay. I try to include in the comment lines the exact name that you should name everything. I just didn't declare it, but I tell you what to declare and what the name should be, what the value reference should be.
So we're just doing the same thing. We got one, just student,
Yep.
RVC student 1.
You're using RVC student 1. Yep. For name ID, name underscore value, name ID underscore value. Same exact thing, but just for RVC student ID prefix.
In old versions of C++, you couldn't. The thing with line 11, I told you about, what you were right about.
Mhm.
It must be because it's a new version. On the old version of C++, you couldn't declare an array that way. You had to say.
Yeah, you did. You're right. Yeah, new version you can.
About this.
Do what now?
I'm not sure what I'm supposed to do on line 50.
On line what now? Let me go back to, I already brought up the answer. Let me go back to my example. Line 52, you're supposed to assign the RBC student name underscore pointer to your own name. So it'll be RBC student name underscore pointer to your name. So equals whatever your name is. And make sure you put quotes in there. Because we're updating that original pointer value anyway. Yeah. So it should be just RBC student name underscore pointer equals. I put Chuck Conkle in mine. And, yeah. Pass these out, so they even review versus screw your eyes on the overhead. You keep working on it, but these are just to help get stuck. We'll go over in a second. Let's breathe on anybody. All right. Some are still working on this, but since you do have the answers here, I'm going to start going over this, if that's okay. I'm about out of steam. All right. On line 18, goes over what to declare the pointer for the RBC student one name. So you should have had string RBC student one name underscore pointer. Make sure you put asterisk there. Then line 20, declaring a pointer for RBC student one ID underscore pointer. Line 22, declaring an RBC student one name variable underscore value, name one name underscore value, string variable. 24, create a RBC student one ID underscore value variable. Then on down to line 52, after comment 51, RBC student name underscore pointer. I put Chuck Conkle on mine with an asterisk since it's a pointer. I'm updating that original pointer reference. Then assigning RBC student name underscore pointer to the RBC student one name underscore pointer. So on line 54, it should have RBC student one name underscore pointer equals RBC student name underscore pointer. Then assigning RBC student name underscore pointer to the RBC student one name underscore value to give the actual value of that pointer on line 56. Then assigning the RBC student ID underscore pointer to your 7-digit ID. Mine's RBC student ID underscore pointer with the asterisk equals 0286381. You put whatever yours is. Then assigning the RBC student ID underscore pointer to the RBC student one ID underscore pointer. This is what we talked about in the reading, also in the quiz, how a pointer can be assigned to a pointer. That's all this is doing here. And you'll notice on that, there is no asterisk on each side needed because it's just pointer to pointer is all we're doing here. And then assigning RBC pointer to RBC one underscore value. Again, on this one, on line 62, you're assigning the value of the pointer RBC student ID underscore pointer to the actual value of that reference. Then see out the address for the student one name underscore pointer. It's going to be different for yours and mine. That's what mine was originally. The see out on 64 should be address for RBC student one name underscore pointer is RBC student one name underscore pointer with an AND L. And then next, seeing out the address for student 1 ID underscore pointer. And 66, the same, just including the RBC student 1 ID underscore pointer for the address 4 and also for the variable pointer. Then seeing out the value for RBC student 1 name underscore value on line 67, first name, last name. Seeing out the value for RBC student 1 name underscore value on line 68 and kicking that value out with the RBC student 1 name underscore value and L. And then lastly, seeing out the value for RBC student 1 ID underscore value. And that should be on line 70 after that comment line, which is value for RBC student 1 underscore value is RBC student 1 ID underscore value. And so I have up here both on the left side the code, the right side the C out, and the address for both. And again, you normally wouldn't do it this way, but this is just to show you how those pointers for both the student name and student 1 name, student ID and student 1 ID, the pointer memory references are both the same for both because it's the same memory reference. The only thing we changed was the value on both. But they did remain the same as far as the memory reference. And so that's yours to keep. For the homework this week, you're going to be doing the replet for week 10. I'll open that up. It's going to be a lot like the first example we did on the average, except you're doing a max value, and you will be returning a pointer. So the objective here is to write a C++ program to find the max of a numbers in a set. So you can do 1 to n on the set. If you want to put 10 in there, you can put 10 in there. If you want 5 in there, you put 5 in there. Doesn't matter. The program will then ask for the user to input those values and plug them in an array. The program prints on the screen a pointer that points to that max value. Now, I said an array. You don't have to use an array. That's what I recommend using, just like in the class example for the average. But you wouldn't have to. You can make it a longer program if you wanted to, but I'd recommend an array just to be easier for you. So the output example here is putting in 3, how many numbers 3, entering each number, and then return key in between each number. So 12, 23, 56. The largest number in the array would be 56. Make sense? And then just returning the max value. I would recommend doing the, if you want, just for practice, to redo the second example again from scratch without looking at the source first to see how well you do without looking at the answer. To wrap your head around pointers and reference pointers and pointing back to a reference and updating a pointer reference and then using that reference. That can be a little confusing when you're first using them. But once you get it, you're good, I believe. Once you wrap your head around it, you're okay. I also put in your note to work on your final app. Even though we're in week 10, it'll creep up pretty quick. Those of you who had me before for final apps on anything, week 15 is going to get here like that. It'll be here. It'll be done. And so I recommend, you don't have a lot of homework to do each week in here, so you could spend a good 2-3 hours a week on your app, easy, and really get a lot done on your app. And that's the whole benefit of doing the app, is not just to get a grade. It's so you're actually creating something you can use with language that you're learning. We've all taken classes, including myself, in languages that every week's a CAM project, and we've done CAM projects in here, and it's great, wonderful, to learn things. But to apply it, I feel it's better, and I've learned it's better personally in my own personal programming life, to have something productive that I can actually use, whether it be at work or whether it be at home or whether it be for my family, my kids, my grandkids, whatever. It makes sense. That way you're actually playing with something and you're building something each week that's meaningful to you. Does that make sense? And what's meaningful to you might not be meaningful to me, but that's fine as long as it's meaningful to you. And every app known to man that's anything today was meaningful to some person in the beginning. Everything from Facebook, Twitter, all these apps that are out, Flappy Birds. Flappy Birds started with 2 college kids in Subway with a napkin, wanted to create a cool game to beat the time in college in between classes. That's how it started. And now they got 550 programmers that work for Flappy Bird. It's crazy. And so, you know, it's kind of crazy how that starts up. And so the ideas you have, you'll never know where I've had ideas. I have on average 30 to 50 app ideas a week. I don't work on all of them, but you know, I have them that I can pull from, and I give them to students sometimes or people that I think would use them and actually do something with it. I give them the idea, because ideas are kind of like, in my mind, kind of gold, really, if you think about it. Just the idea for an app. There's so many out there, right? But here's an idea for an app I'll show you. I'll tell you about. The 3rd, 4th grader kids, right? At the last session, I asked them to give me an app idea on the fly. They had no prior knowledge of what I was going to ask them to do. This girl in 4th grade said, and I only had a minute to think of one. And I had about 12 kids. I had 1 minute to think of it. This one girl came around. They were all great ideas, but this one really stuck out to me. She said, I think an app for kids, an Amazon app for kids, that's like kind of YouTube Kids kind of app, but for Amazon, where parents can put a cap each month on the Amazon account. It's going to be kid-friendly items that the kids can order, and the app will allow the kid to talk into the app if they're young enough to where they can't read yet or type. They can talk into the app what they want, and then they get literal cap where the parent, they can literally order it themselves, come to the house each month, $10 a month or whatever the parent wants to do, and the kids gets to experience and learns some responsibility, like on, you know, what items are out there, what they might need, what they might want, to differentiate the two. Because each month, if they don't spend the cap, it gets to carry over to the next month. And so it's a great idea. I mean, it's like a 4th grader.
Yeah,
right?
Kids are smarter than us. They don't have as much time.
No, I mean, it's just amazing what you can do if you just stop and think about, like for you guys, you think about it for a second, at your age and your structure in life and what you're doing right now. What kind of app could you create that would make your life easier and students around your life easier? Stuff like that. Those ideas can just like go crazy without any limitations or without any type of barriers, because your creativity, in my mind, is what sparks a passion for me anyway to code, is creativity for ideas, right? Because to just code is boring, but code to create something that is useful is pretty powerful, I think, right? Otherwise, you know, we can all flip burgers, or I can do construction for years. I can do that. I mean, it's not a meaningless job, but I don't have to think a lot, right? To do those type of jobs. It's just a do this, do that, do this, do that. But programming, if you think about it, you're creating something from nothing that doesn't yet exist, if you think about it, right? So that's hopefully something to inspire you in your final apps. I know you all have great final app ideas, but maybe to inspire you to put a little bit more thought into your app ideas and more time into it. Because in my mind, you never regret. I have always regretted not spending enough time on some certain portion of an app. I've never regretted, spending too much time on an idea that actually was useful to people. You never regret that. Just like volunteering or something like that. It's kind of what I look at it. So even if the app only, helps 100 people in the world, there's 100 people in the world. That's pretty good, right? You're helping 100 people. If it's only your business, it's your business. That's pretty good. So anyway, I'll get off my high horse. So lost. I don't think it's a cold medicine speaking properly. But anyway, for this week, you can, like always, you can do more than what's expected. Same with your final app, do more than what's expected. But I want you to challenge yourself on it. And that's all I've got. If you did not check in, please come up and check in before you leave. And reminder, this Thursday and Friday, the campus is closed. Thursday for faculty development, employee development day, and Friday for Good Friday, I believe, right? Good Friday on Friday. So just beware of that. I did email all my students that are my 110 and my 245, I believe, about that. So anyway, we're still having our classes, by the way, even though we're not meeting face-to-face. We can afford not to have class, so we're going to do it online. So anyway, if you need help, come and see me. Otherwise, we are done. And if you don't want me to breathe on you, understand that. Yes?
I was just curious. So when would you use C++ or C# or C++?
Would I recommend C# over C++? When?
When? Yeah,
Oh, when would I do it? Oh, good question. If it's a GUI based app, C#. If you want tutorials on that, I can give you some. If you've not taken C++, C# yet,
Yeah, I'm gonna take it next semester.
I can give you some tutorials to help if you want to play with it. It's up to you. Like, you know, the hello and how to build a simple, you know, form-based app. And
I actually want to kind of planning on in between the two.
because you were doing what, were you doing a calculator or notepad? Notepad, right? Were you doing a notepad type document? Yeah, the C# would probably work better for you. I'm thinking.
I think I'm just gonna stick with what I'm
Yeah, dude, stick with what you're doing. Okay.
I was just curious because you know it's like
Are you just doing like a C++ with a file in, file out type stuff? Or you don't
yeah,
just?
so far I just have text box right now.
Okay.
And you can change you can add text to it. You can do new.
Yeah,
erase everything.
that's fine. For first version, that's fine, I think. Yeah, that's fine. That's perfect for version 1. I think that's great. Yeah. Now there is some plugins on if you want to, you don't have to. There is some plugins through a backend database that I recommend that's out right now called Firebase. I don't know if you've heard of it. It's a Google database based on JSON that we're actually starting to use in my 254 class or 245 class for Android. But you can, when you write files on that one, it actually saves it in the cloud, and then you can read from the cloud. But you don't have to do it that way.
Yeah,
Maybe that'd be a future version. Yeah, that'll work. Sounds good, man. Sounds great.
I have a question. If
Yeah,
we
yeah.
put something down in like our ideas for final up, is it possible to change it?
Oh yeah,
Like,
for
we
sure.
wanna do something
Yeah,
else.
that was
Okay.
just their beginning ideas. Definitely. Yeah, good. That's a good one. I didn't mention it. Yeah.
Thank you.
Yeah, kind of add to it or change it all totally.
Yeah,
That's fine
like,
by me.
completely change it.
Yeah, just do me a favor. When you change, if you do change it like totally, if it's adding to, don't worry about it. But if you're changing it totally, just go into the week that you submitted that. You can change that, by the way. Even it won't change your grade or nothing.
Okay.
It's already been graded. It just kind of prompts me of what that change is.
Like in the discussion, or is the week? Put
The week we actually did, I think it's week 3 or 4. I can't remember what week it was, where we actually did the final app submission thing, the app idea. I think it was week 4, might have been week 5. I don't remember. So I think whichever week it was, you can update it. It'd be great.
Okay.
Cool. Sounds good. Yep. Yeah, I'd rather you do something that you're going to want to do. So yeah, if you're going to change it, go ahead and change it. I'm fine with that.
Are we here?
We are here Monday. Yes, we are here Monday. Unless something's been changed that I'm not aware of, we are here Monday. Yes. Oh, they do? Oh, yeah. Well, no, we're off Friday, but we are off Monday. We are here Monday. Yeah. Yes. Sure. Yeah, definitely.
I did your character. I know the characters are I go like weird.
Where are you doing this? Where's this being kicked out?
It's the same thing you were doing.
Uh-huh.
I did it with character.
Oh,
I
yeah.
have my character and then
Just shove together the asterisk. Get rid of the space in between the asterisk and the M on both, on line 20 or 75.
I'm only using one.
Yeah, go ahead and do it on which one, and then go ahead and run it and see what happens. If you have a space, it will do some funky characters in there. And you're doing char values too, that's why. Yep, you're doing char instead of string.
Yes, that's I did that in purpose. I mean,
Yep.
like
You know, it's going to do that on char CL.
Yeah, make it a string.
Make it a
if I
string,
make
it should
a
be
string,
fine.
it's fine. I mean,
Yeah, that's fine.
We
Yeah.
know that already, but I was trying
Yeah,
to.
the char value, if you're going to do a char CL, you're going to have to loop its character by character to show it as it was in the
That's what you had
string.
to do with it. Do a care star. Do a care star. Do a care
Yes,
star.
that's what I have character.
Care, yeah, but make both of them care star. Make both of them first.
I think he's only using one right now.
Yeah, so just make, yeah,
Yeah, but then I'm like,
right.
Then get rid of that space. You need a space on 75.
wait,
Between, yeah. Yeah, I'll show you.
All right, and you just, what is it, You just.
Yeah.
And see, he's just seeing out a character. It's not going to work. I mean, it'll give you the funky characters when you see out char by itself.
so I guess it's normal, I guess.
I'll try.
Well, if you're going to do char, you have to loop through each character as an
But it's
array.
just one character.
It doesn't matter. When you do a C out, it's going to be one. It's going to still need to have, you're still going to need the code for that char pointer. Because it's actually showing you right now,
This
You
one
look
works,
at-
so it's doing,
seeing out my character, put an asterisk in front of the C out for me. Put an asterisk in front of the M on line 78.
yes, right.
Yep. And then run it. Yeah, so you cannot convert a char to a char pointer because of that. So char pointers have issues.
okay, so
Yeah,
this is.
char pointers have issues. Yeah.
No,
That's why I use string.
that's
string
what
is
it
recommended. String is recommended.
Just give it a quick quote. So you just want one character. So you just see how my character, that should put an I, right?
Yeah.
And then you want the pointer, right? So let me show you. All you have to do is see how, all you have to do is my character. I'll put an emphasis in front of this. Show you. Just think of an emphasis as a triple. Does that make sense? Try it. Cool.
Yeah, the whole example I built was on string, so it's going to totally screw it up. Because the original, the original pointer was a string, and now we're converting it to a char, and it's going to go no.
Super.
Hey, we'll see you.